We are live. Hello, everyone. Welcome to this month's Loki Community Call. In case you hadn't figured it out, we're actually in the same space right now.
It's quite special, right? Live.
Yeah, it's super special and also super nerve-wracking because we're on hotel internet. So we just arrived. Like Jay and I just landed
Dylan
like
is
a
also
couple
super
hours.
worried about the Wi-Fi because he could barely download anything over Google Drive.
Well, we'll see how this goes. So tell us if like any of the audio is messed up or anything like that, because we're kind of just like figuring things out. But yeah, hi, I'm Nicole van der Hoeven.
I'm Dylan.
And I'm Jay Clifford, partner in crime, as always.
Yeah, and just because we already asked him for his last name, then did not pronounce it at all. This is Dylan Guedes.
Guedes, yeah.
Guedes. Oh my gosh,
No,
Guedes.
you said it right.
Okay.
Yeah, don't worry.
I already pronounced it wrong. Dylan, why don't you? Well, actually, before we do that, let's talk about some announcements. We actually, maybe Jay, you should talk about GrafanaCon.
Yeah, I mean, we just celebrated GrafanaCon in Seattle. So we was there all of last week. I think we had 531 people that actually came in attendance, which was wild. And then over 1,000 people on the actual live stream attended, which was awesome. So yeah, we had some crazy announcements. We sort of announced for Grafana 12. We had like Git sync, so you can now like programmatically sort of deploy your dashboards. We announced Pamir 3.0. Loads of crazy announcements. We're not going to cover them here because this is a Loki Community Call.
Yeah.
But there's loads coming. All of the videos are going to come out in about 3 weeks, I think. The Loki team, our content team said. So if you're feeling the FOMO of GrafanaCon, as Nicole
totally
was,
did.
You can definitely see them there. But there was so many Loki community members there, and so many Loki sort of Grafana aces. Grafana champions.
Wrong company, Jay.
Grafana champions for Loki. So it was super cool seeing them there. So it was brilliant.
Yeah. Actually, the keynote is already up because it was live streamed, so you can already watch that on the channel. And then I did like a 1-minute YouTube short to just be like, here's all the things you need to know that was announced in the keynote. What else? On the Loki front, we also got a new release. 3.5 is out. And there's a lot of the main things that I think we want to talk about is some improvements to the Helm charts in particular. And then maybe talk a little bit about the storage.
Yeah, I mean, we had a lot of improvements in the meta monitoring side too, but I'm very excited for the improvements that we made to the delete part of Loki. We are now able to to recover things for a SQLite database, and that is speeding up the delete queries by a lot. So users will probably notice a lot of improvements on that side.
Oh, amazing. So Dylan, we've got you to speak about features without actually introducing yourself. So tell us a little bit more about yourself. When did you join Grafana, and what do you do as part of the Loki team?
Yeah, so I joined almost 3.5 years ago.
Congrats.
Yeah, and since the beginning, I was already contributed to the log side of Grafana. So Loki, enterprise logs, and Grafana call logs, all of that, I tried to help with, yeah.
Oh, fantastic. And more on the ingest or query side, or a bit of everything?
In the beginning, it was on both ingest and on the query side, but at these days, it is mostly focused on the ingest part of it.
Oh, fantastic. Brilliant. So you're the one to blame for the 254 kilobyte limit on Loki log ingestion. And rightfully so. I'm fully with you. We've had some interesting cases in the community at the moment where people are trying to ingest logs of 3 megabytes in size as body, and I'm like, oh wow.
I'm sorry, guys. Yeah, that's not the best.
So that was actually reported. Single-handedly. So today we're going to talk about just what it takes to maintain a reliable Loki. Right. We use Loki internally too for our own stuff, for our customers, but also for us. Like we just use all of our own stuff, all of our stack to monitor our production environments too. And I think we're not actually the largest runner of Loki. I think we'll probably
the second, yeah.
Yeah. But that's why meta monitoring is so important, right? But can you talk a little bit more about what that is?
So meta monitoring is basically you having a dedicated observability stack just to observe your own Loki instance. And yeah, it is pretty much required once you reach some level of seriousness on your Loki instance. Otherwise, like you won't be able to tell what is going on if your instance gets unhealthy.
So, in terms of meta monitoring, you sort of alluded to it there. There's the ability to we use another stack to monitor Loki itself. And is that like metrics and logs? Do we look at those?
Yeah.
And what? So, what do we actually use our own stack to monitor Loki itself?
I mean, so it is important to have an isolated environment just to monitor your own Loki environment because if something goes wrong, you can still like rely on your separated instance to like find out what's going on. Let's say like you deploy something wrong to another Loki instance. If your meta monitoring is not separated from that, you won't get like pages for it. So that's why it is important to have it isolated.
Ah, interesting. And I'm assuming this is a practice that we deploy in our own cloud environments for ourselves.
We do the same thing on our side, yeah. Uh, so the names are not the same, but yeah, we try to. So for all the production environment, we have like a thing that you can consider meta monitoring just to monitor those things. And we didn't mention traces, but we also like to look at that too.
Oh wow! So like I guess we've got 3 telemetry signals there, then metrics, logs, and traces.
With all
Oh,
of
for
that.
Loki, fantastic.
So why meta monitor Loki specifically? Like if we think it's so reliable, I mean, sometimes I get this question like, oh, why do I have to meta monitor it if it's supposed to be reliable? That's what it's built for.
Yeah, that's a good question, honestly. But I think it is because of the complex in the nature of like the system. Depending on how you are using it, you can just make it to consume too many resources.
Yeah,
Or like let's say you want to update something, maybe your update has a regression on it,
yeah.
and you have to have ways of like telling what is going on. So that's why it is so important.
I also imagine that it would also have compliance things. Like some people might need to be able to show some logs, like if it's security access logs or something, not being able to access those logs or losing those logs, that's really critical. Like that could affect compliance.
You
So
are
it's
absolutely
it
right.
has other implications, not just for being reliable, right? So we definitely want to make sure that we still have those logs.
Absolutely, yeah.
So there's actually quite an interesting question in the community there, and it's kind of Dylan, you can allude to how much we're allowed to talk about our own infrastructure and not. But Jiffy,
Jiri.
Jiri,
Judy
Jiri.
Rolicek says, I have a question. Do you actually run multiple Loki instances per service, team, or environment? Or is it rather one large Loki?
We have a single big meta monitoring for all the different environments.
And then, so do we keep separate clusters of Loki, and then we have everyone as a tenant on those different clusters depending upon the region
Exactly
you're in?
that. But we have multiple of those, but the meta monitoring itself, we only need one. Like we could have a single meta monitoring for all of those, but so far we haven't like find the necessity of it.
Fantastic. So yes, one central LGTM stack where we basically aggregate all the metrics from all of our Loki deployments and make sure we have uptime for each of those.
Exactly.
Brilliant.
We also have a question from Harold or a comment that says that they've just been discussing that Zabbix monitoring LGTM infra, which in turn monitors LGTM prod in case creative application devs log very large stack traces and such. Yeah, because like sometimes, I mean, if you're logging absolutely everything, that's a great way to cause problems or just also kind of cloud issues if you're logging too much. Even queries, right? If someone is has written and executes a very poor performing query, you don't want that to stop everybody else from being able to run those queries. Those are good reasons to monitor Loki.
Exactly.
Okay, so what's it? So you're on call.
Yeah.
What's that like for our own stuff? Like, what's the setup there for meta monitoring Loki?
Yeah. So in general, like being on call, so we have been doing a lot of improvements. So it is not super stressful these days. It is quite often very calm. Uh, but it is so normally what happens is if something goes bad, which doesn't happen often, but when it happens, we rely on our tools and all the data that we have to tell what is going on,
Yeah.
and then we try to triage stuff and act based on what we found.
Yeah. Well, I really like one cool thing about Grafana is that we have the Loki team actually monitor Loki in production. So we don't have like we do have an overarching like platform engineering team, but they're not responsible for the individual components. The people who are responsible for making sure it's up and running are the people that are building it. So you don't get the silo of like, well, we just do the code, you deploy it. Like, no, we're making the code and we're also making sure it's being maintained.
Yeah.
So that's really good.
So Dylan, like when you're on call, what are some common issues that you see? Is it noisy neighbors? Is it like what are some of the common issues you've had to solve on call?
I mean, fortunately, as I said, these days it is a lot of days they are super calm.
Yeah.
But when it happens, let me think. Yes, in some cases it is something very user behavior driven, like a user,
Queries?
like bad queries for
Yeah.
something is going really wrong in the user side, and they start to emit a lot of logs, and your limits and stuff are not defined for that. Yeah, so we have to act regarding that. Another issue that we see not super often, but it can happen is when you emit a delete request and your delete request is it touches too much data, we might get paged for that. And in that case, the solution is to tune the delete request a little bit.
Hmm.
Yeah.
Okay. We have a question here. Um, Luis Schweigard says our Loki read performance tends to spike by a factor of greater than 10 after the read pods in SSD mode have been running a long time and restarting them solves the issue. Any ideas what this might be about? First of all, just a note there, the SSD mode, which Luis mentioned, is technically not supported anymore. That single scalable deployment we would recommend. Well, I don't know if I'd say it's not supported, it's just not going to be supported further. We would recommend switching to the microservice, the distributed mode, just because that doesn't just separate it into the read and write paths. You can then tune every component separately. So that's one thing. Sometimes if you're using SSD, it might like cloud a whole bunch of things. So Luis said it's the read path, but like what part of the read path that kind of gets lost sometimes.
Yeah. I mean, we would have to look at your metrics to really tell what is going on. But just to double down on what Nicole just said, we are slowly reducing the contributions to SSD because it is not the deployment mode that we use on our infrastructure, and we have been finding it hard to dog food it. So it is always the community has to find the issue for us to work on it. It is not super practical, so we are encouraging people to move to distributed, or even you can have single binary but run multiple instances of it. But regarding your issue itself, if it is because you've been using Loki and now something is going on your infra and killing the pods fixes it, it might be that you are retaining too much data somewhere, on your index for some reason. So I will look into that, what your uh, what the cardinality of your logs are, maybe, and what your queries are looking like, because maybe you are requesting data from too many different indexes.
I think this is like a cool plug for the meta monitoring that we'll talk about, because I think Lewis is probably already meta monitoring, but if he can start taking these snapshots, especially of the logs and where the metrics are at, and if we can put them in an issue, we can have a look at them after the fact.
Yeah.
have a bit more specific issue.
Yeah,
Good question.
I was going to say, I feel like this is a very good scenario to justify like having meta monitoring, honestly.
Yeah. Well, okay, so let's talk about that. What exactly should we be monitoring? We have a question from Matt on our Grafana community Slack. I believe he's also in chat.
Hey,
But
Matt.
hi Matt. Don't worry, we
We've
didn't
got your
forget.
question.
We've got your question queued. We got you covered. What log levels are worth capturing and looking at within Loki? Like the follow-up question is, should I only care about errors and above, or like also warn or debug?
I mean, it is worth having all the different levels, but like the more details you need, the lower level you have to look for to know what is going on. So, for instance, if you just notice that something is not working, you can start by just looking at the errors. But let's say you already have a hypothesis of what is going on. That's where like you probably want to look at the debug logs too.
So in that sense, then, so I guess that the debug logs are just going to emanate just way like the volume of it is just not necessary. So is there an easy way of triggering like turning debug logs on? Is it purely just like a config change in Loki?
It is, yeah. It is super easy. It is a dash flag that you can use. It is log.level, and so it is pretty easy. But maybe you have to restart your pod. That's the only problem with it.
And then you can, and then basically you probably just take for a snapshot, try and reproduce the issue in that debug time, and then disable, go back to info or something like that.
Exactly. Another approach, like you can do if you are using Grafana Alloy, is you can tell Loki to generate all the different log levels, but you can say Alloy to discard all the debug logs.
Yeah, that's so cool because one of Alloy's strengths is that it also has a data pipeline. So it's not just a forwarder of data. You can also say like, okay, from this subset of data now only send through this smaller one, and you can also change that with configuration. I think in general, maybe capture as few logs as you can get away with. But then if you see that the same components are raising alerts because they're getting degraded all the time, then maybe you should think about increasing that so that you just have more context in the next case.
So we've sort of talked a little bit about logs as a signal, and there's also metrics that come from Loki, right? So it's like Prometheus style metrics.
Right.
I think we can like sort of add this into Matt's other question, which is what are the top indicators that Loki is healthy versus degraded? And I wondered if you had sort of an overview, Dylan, of sort of what's the type of metrics that we log in Loki/metrics, and which are the ones you think you use quite a lot, which ones are important in the health of Loki?
I feel like the best answer for that is so we have the Loki Mixin, which is a collection of dashboards that are very similar to the ones that we use internally. And I feel like this is the best starting point for someone like trying to understand what is going on with their Loki instance. So on the dashboard, you'll find like the most useful metrics, which are the best indicators of how your Loki instance is going.
I guess what we could do is we could flip it. We could talk about Loki Mixins now first if you wanted, and then we could then go, how do we get all these metrics in the first place with the Helm?
We can do that.
Sweet.
And also, I have a question that about the Mixin, because like we also now have the logs drill down, which is part of the drill down apps, which are on Grafana Cloud, but they're also OSS. Because that's also kind of the premise of logs drill down, right? That it automatically tries to determine what the services are and then provides you with like dashboards and stuff. And so like what's the difference between the Mixin for Loki and the logs drill down?
Because the Mixin, it is a more direct definition of things. For you to know them, you would have to use drill down metrics, and you look like at a bunch of metrics, but you still need to know which are the ones that you should be attention to. But if you are using the Mixin instead, you can like pretty much just look at the dashboards, and all of that will be useful for you to know. So I feel like that's the biggest difference. You don't have to filter data.
Okay. What are we looking at here?
So this is the so we have the
Can we
precompiled.
embiggen this? Sorry.
Yeah, sorry, my bad.
No worries.
There we go. How's that?
That's
good.
good.
Yeah.
So on our repo, on Loki repo, you'll find a folder like with the mixins precompiled. You can just import them on your Grafana by going to new and then import, and you can import the JSON files, and you have those things. But yeah, those are like the main dashboards. This is very similar to what we have internally, and the two ones I think most users will benefit from are the reads and writes one. Uh, they are very focused on the read and on the write path, and they will give you a very good indicator of what is going on with your instance.
So I guess if we sort of drill, maybe let's start with the right path,
Sure.
and I think this sort of plays into the question well about what Loki metrics are looking at. So could you sort of take us through a bit of a tour of the
Yeah.
right dashboards and tell us what we're looking at and potential issues that you might see, and how people can read them and understand what's going on?
Sure. So in this case, it is a distributed mode. So this is not super applicable to if you are using a different mode, but imagine you are using the microservices thing. What you find is it is separated by components. As you know, Loki has a distributor, an ingester, and many other components. So, but for the right path, the two ones that you should be aware of are the distributors and ingesters.
By the way, quick plug. Jay and I did an architecture video for Loki. So we're going to be talking about different components, but we go through all of them in the video. So check that out. I will add it below after the stream. Go for it.
So for all the components, you'll find like the QPS, which is how many queries are occurring for that component. This is really useful for you to tell like if something is going bad because someone is doing a lot of work, like you see the QPS is spiking. We have the latency, which is separated by every pod or in general, like everything aggregated. This is super useful for you because sometimes you're not seeing errors, but your queries are taking super long or your writes are like timing out. And this is how you can say if that's the issue or not. We are not seeing data here for the ingesters because on this deployment, we are not using zone awareness, but we would see like the data here if we were.
So which of these have alerts on them? Because Matt had the question, what are the top key indicators that Loki's healthy versus degraded? I imagine like you're not just watching this the whole time when you're on call, right? You get alerts. So what are the alerts on?
I'm not sure if in the mixing it is the same alerts that we have internally, but internally we try to, so we have SLOs for all the different services and stuff. We try to page like if we are getting the SLO super degraded, so we can act upon that. We also have alerts for like when a hardware issue is going on, like let's say we are opening too many contract connections or pods are getting killed or panicking. We have also alerts for that, and I recommend like having alerts for those things.
Interesting that there's an alert for having too many compactors.
Yeah, because we only expect you to have like
one
compactor.
ever. Yeah.
And I think that's an interesting one people have to realize is like they have more than one compactor that actually cause themselves lots of internal issues with Loki. So yeah, if you have more than one compactor running, check that. You probably have issues running with Loki. But there's a few that we've sort of given out of the box, and I think this is something that we sort of hope to expand in the future. I think like these cover a broad set of like when Loki is fully collapsing, right? We have like Loki request errors, which kind of takes a look at like the different paths, whether it be query and write, and checks if the percentage, if there's a number of like failed requests every certain amount of time. Or there's like the Loki panics where there's literally like one of the components is just falling over. So I think we covered general catastrophic scenarios. But is the goal here you kind of, if you get an alert that fires from IRM, would the option be to then go to that dashboard based upon the specific path that's been triggering errors?
Exactly, like by the alert name, you can tell if it is more related to the ingest or the query path, and you should like start from the two dashboards I mentioned, like the write and the read dashboard.
Nice. I guess so. So say there was having an issue with the ingest path, and if we jumped back into our dashboards, looked back at Loki Mixins. So we talked a little bit about the distributors. We don't have Sonaware ingesters, but I'm assuming it's kind of like the same sort of setup for both distributors, ingesters. Is it? I mean, would you check? Would you start with distributors first and then move to ingestors and work in sort of like a sequential order to see where things go wrong?
Exactly. Like in some situations, you will see that distributors they are showing perfectly, but the ingestors are the ones that's struggling. And you can easily tell this by this dashboard. So yeah, that's pretty much what I would do.
So when you say that the distributors are showing up perfectly healthy, like what is it? Are you looking at CPU utilization, memory utilization, errors, latency?
Mostly errors and the latency. Like for instance, we can say like 5 milliseconds. That's really good, and we can see here we only see 2 XX and no 4 or 5 because we haven't seen any errors on this instance. But if we had, we would see that in the dashboard. So that's how you can judge like that distributors are healthy. They have no errors and the latency is good. We have errors now.
So I use K6 plug for this, and I think what I did here at this specific time was I said to K6, I was like generate logs with a trace ID label, and then I generated up to 100,000 trace IDs and put those in the index.
It's great.
Impressively hard to like upset Loki, which really struggle with. I think ingest is super good, right? It's like it's the query side. It's like fails more than the ingest side.
Yeah, it is pretty hard to do the rights wrong. For the queries, yeah, depending like you won't need a lot of work to make a very bad query.
And then like so when we sort of split out the errors here, any 2xx errors is okay. I'm assuming is any 4xx errors usually like limiting issues, like if you're being blocked by one of Loki limits?
Exactly. In most cases it will be 4xx. Yeah.
Interesting. So that's like if you're trying to ingest say a log line that's too big based upon the limit, or like your throughput is too much for what your current limit.
Exactly. And this distinction, like it is quite important because if we really want to retry errors that shouldn't be retriable, or let's say we are like rejecting your log line because it is too long, you retrying it won't make it shorter, like it will be the same log line. So we don't want to retry that.
Gotcha. You just keep reiterating, and then any 5xx errors is just where we're at action stations. This is bad. We shouldn't be returning 5xx
bad
errors.
Gateway.
Nice. We got any questions in the thread, Nicole, like as we go through to check?
Well, there's one from Roman Mikolaevich. How do you prevent ingester pod from running out of disk space? So I wanted to say this one because I also wanted to ask, like, do we use Pyroscope?
We do.
Okay, so we also use profiling. So it's actually for telemetry signals.
We
use logs, metrics, traces, and profiles for Loki stuff. Okay.
Right. It is not on the mixing, but like if you manage to integrate it, it is not a lot of work. But if you manage to integrate it, it will be really useful for you to tell with more details what is going on with your instance. But to your question, how do you prevent the ingester from running out of disk space? So the ingester will use the space probably because of the wall, the write ahead log. So I would say if your disk space is not too low, it is probably that you have to tune the wall usage. But yeah, you can. The other situation is you can just run too little on disk space because it will rely on that.
So yeah, so interesting there. It's like your write ahead log should keep increasing. Like your write ahead log should flush, right? And then like you should then that reset. So this might be a potential issue to look at why their write ahead log is constantly increasing.
Yeah, but like you have to have at least a minimum amount of disk space for that wall case, and then it's supposed to never run in out of disk again.
And I'm assuming that WAL is dependent upon like the size of Loki that you're running. So like, is it if you're depending on the amount of the log volume, would dictate your WAL size just based upon, say, if you have a problem and you can't flush, you want a decent enough WAL size to be able to.
I mean, after a certain volume, you don't have to care about like increasing your wall, because it won't ever like be the cause of like an issue you're seeing. But yeah, if your cell is like your cluster is too small, maybe you have to tune that.
Okay, yeah, interesting. So yeah, I think to the question, that's a really interesting point. So yeah, it'd be interesting to check if they did meta monitoring to check whether their WAL has actually reduced at all, or if it's like, are they actually seeing flushes to object storage, or there might be a bigger problem there that they need to check out. So this would be quite cool for them to see what comes back with meta monitoring.
Right.
Okay, so shall we move on to how to get this data?
Yeah.
Was there any? Oh, what did you want to also go through the reads dashboard?
I think that'd be cool. I think just to finish up on the rights there, so we complete the process through. So I think we had the ingest, which is very similar. The index,
the index, yeah.
Index looks interesting. So what is the index? I'm assuming based upon the index component, index API, index gateway component.
It is. Yeah. Basically, like while we are ingesting stuff, we are keeping some data in memory, so that's why you are seeing some data there.
And it's the same again, so queries. And so with the index gateways, the queries per second, it's purely either the querier looking at the index gateway to see what, like, retrieve the current index for those queries, or
exactly. But I mean, from my experience, like the right path has very little to do with the index gateway. So I recommend users to not bother with that if you know that your issue you are experiencing is right related.
Gotcha. Okay, and that's purely like, so the right will basically, the right path will forward the new label series. Sorry, the new label flows to the index path. So I forgot the words, not label. Label streams, log streams. Yeah. And then bolt index we deprecated, so we're just ignoring that.
Yeah, this is old stuff.
Sweet. And I guess we could talk a little bit about like how data comes in, and we can always revisit the other dashboard components.
Yeah. Okay.
Yeah.
So it seems like the question of where to get meta monitoring for monitoring metrics and logs for Loki is something to think about. Like it seemed like, and I'm asking both of you here, it seemed like there were two main places. You already mentioned slash metrics, so your deployment of Loki slash metrics, that's like a handy API endpoint for Prometheus style metrics. And then when we had Ed Welsh on, he also mentioned metrics.go for logs. Are those the two main places that you would get information about Loki?
Absolutely. Like especially the metrics.go log line, it is extremely useful. And this is a good example. Like at the beginning of the meeting, we were talking about like the debug logs. The metrics.go is a one which has the bug level, and it's still like it is really useful for stuff.
And yeah, I think like for me as well, it's like the one thing that kind of like doesn't get covered in the Loki metric side is if you've deployed each component, then it's good to collect the pod logs as well. So you get most of the information about like general state of those Loki components running. So we kind of enable by default in the Kubernetes monitoring Helm pod logs. So you can at least see those in there, and we can always revisit the dashboard later. We have like a logs dashboard panel to see it. I guess my own question from the metrics go, is there anything that you need to do in the Loki Helm config to enable the ability to query from metrics.go, or is that always enabled and you can just pull?
No, you should like have the metrics.go log line like by default.
By default?
Yeah.
Sweet. Because there was a question from one of our solution architects, was like they had specific Helm parts enabled, and that gave them specific stats over query performance, and like when a specific query runs, they could see like the latency, like how many how much sharding it's broken into in different parts, and I was just wondering if that's something people need to enable or.
No, I mean fortunately it is enabled by default. Yeah.
Fantastic. Oh, that's pretty cool.
Okay, so what things would you get from metrics go that you think are particularly important?
I think the most important things from metrics.go is like it will tell you how big the query is, like how much data it is touching the query itself, so you can see if it is a bad query or not.
So it's mostly from the reading, if you know that it's read errors.
Exactly.
Yeah, okay.
Yeah. So, for instance, if you are paid for reads degradation or something, you would go to the Loki/reads dashboard, and if you have the hypothesis that it might be on one specific query, the next thing to do would be to go to the metric.go log line and search for like what is the bad query that my system is
Yeah.
looking for.
Do you ever use Logzilla?
I do, but like since we have a Grafana setup done, we don't need to use the CLI terminal. But yeah, for some cases we use it.
Like, what would you use it for?
For instance, we have a product called the Cloud Logs Export, which allows you to export data from your Grafana cloud to your own bucket, and to retrieve that data. I find it more like easier to just use Log CLI to for your data remotely than just spinning up a new Grafana instance just for that.
Okay. Let's talk about this question from Jiri. Do you decide it's time to add labels only based on the speed of filling the chunks, or do you look at other metrics as well?
It depends.
So I'm assuming like they're trying to understand the question a little bit there.
Yeah.
So is it based upon like, is it like a labels best practice question of like, are you only adding labels to making sure that your log streams fill chunks to an efficient level? You're not creating too many log streams for the sake of.
I guess I would try to go back to like, what is the problem that you're trying to solve? Like, are you trying to do this because you are seeing degradation? Like, what degradation are you seeing? Are you having performance issues, or I wouldn't jump to adding labels.
Yeah.
I personally would want to know exactly what's going on here that makes you think you want to add labels.
Yeah, I was going to say like filling the chunks too fast is not a problem per se. So you don't have to add new labels just because of that. Maybe your set of labels is perfect for your use case. It is just that your volume is getting higher, so you will eventually fill chunks faster.
Oh, some extra context. Speed of queries, but we're running monolith deployment still. We did a Loki community call on sort of best practices for querying, since that seems to be specifically what you're asking for. We did an hour on that, and a lot of it was actually not architectural. It was more like, here's how to formulate a query, because it might just be an educational thing. There's a lot of things that were not super intuitive to me that I'm like, oh, I didn't know that that's how you should do a query. Yeah, like we start with regex, of course.
Please don't do that.
No, don't do that. I'm joking. But yeah, that might be helpful. Harold has a question. Do you recommend to look for queries looking at a large amount of log data, similar to temp space or unindexed query monitoring in a database? So in same answer, look at that Loki community caller. We talk about queries. This is one of the unintuitive things, because I thought it had to be like start with a very. I think we did a postcode lookup example. So I thought like, maybe I should query first for the country, and then the region, and then the postcode and something. And then we were told, no, if you know the postcode, just go for the postcode. Like, don't worry about doing a large thing. Like, go as specific as you can already, so you're looking through less data to begin with, which that's not initially how I started writing queries. Maybe we could talk about how to deploy meta monitoring. Like, what does that look like? And we can talk about Helm stuff.
So I think we can talk a little bit about the history of where we was.
Yeah.
So when I joined, which was only a year ago, which is wild, we had the Loki meta monitoring Helm, and this kind of sat as an independent repo that contained like a very custom Helm for Loki that had the ability to like scrape those metrics, like the Loki endpoints for each component. It had the ability to do like the logs and so forth, and it it worked for a while. The problem is that the actual project itself wasn't kept up to date, and so we had lots of people that were putting issues in there, and we weren't getting around to fixing them quick enough. So what we wanted to do was find a better way of doing a more unified meta monitoring solution for not just Loki, but for Tempo and Mimir. And so what we realized is that, we're advising people a lot of the time that, you should be running in distributed mode, you should be running on Kubernetes to have a production ready deployment. There are plenty of other ways you can run Loki, but this is the way we personally would like you to run Loki in order to be able to support you in the best way in the community. And so what we realized the best route forward was the K8's monitoring Helm. And so the K8's monitoring Helm has been around for a while. We originally created it as part of our K8's monitoring stack for Grafana Cloud. It's like, so when you use the K8's monitoring wizard, I think I can even, I don't know if I share the screen.
Yeah.
There we go. Inception. If we look at this Kubernetes app here, you might see some of the metrics because I've got it deployed, but this app runs based upon the Kubernetes monitoring Helm. Now, the cool thing about the Kubernetes monitoring Helm is, although the Kubernetes app is a paid-for item on Grafana Cloud, the Kubernetes monitoring Helm isn't. It's completely open source. And you can go to the repo here. So we go, hey, K8's monitoring Helm chart. You can find it here. And what's interesting about it is there is a ton of features that's included in the K8's monitoring Helm, especially shout out to Pete here. He's awesome. He actually does his own office hours, which you should check out. There's a ton of features that are in the K8's monitoring Helm that's actually not accessible via the UI currently. And that's what we tap into. So there's a ton of integrations in the K8's monitoring Helm that's contributed by a few of our solution architects, as well as people which are specific to Loki, Mimir, Tempo, and Pyroscope. And they basically allow you to tap into each of those databases like independent metrics and logs.
I also put a link in the description already because I knew this was coming up. Jay just mentioned that Pete does the Kubernetes monitoring Helm office hours. And so there's already a playlist on our YouTube channel for that.
Yes. And like, it's one of those things, Pete is super integrated into the community. So please go along. And if you have anything to add to it, he is all about it. I think without getting too deep into, I feel we're stealing his thunder a little bit, but to give a bit of an overview is we decided to take this and said, look, this would be a very nice way, a generic way of monitoring Loki in production. And so what we decided to do was curate the K8's monitoring Helm values file specifically for meta monitoring Loki. And so if I jump over on screen here, if you jump into our Loki repo and go to Loki production Helm meta monitoring values.yaml file, you can see the values file here. And we have now just released documentation as well, which we can talk about in a bit on how to deploy this K8's monitoring Helm.
Awesome. Run us through it. Well, we've got a Prometheus instance.
Yeah, absolutely. So so essentially what we have is you kind of break it out into a couple of areas. Global parameters that you see at the top is basically enabling how each component that you have, like each source, will operate. So at the moment, we're basically telling everything to have a 15-second scrape interval. And that's based upon currently how the Loki meta monitoring recording rules are set up. The queries expect you to have points, like at least 3 to 4 points in a minute, which is not always great for Grafana Cloud, and we'll get to that at the end in the gotchas for the values file, but just for the sake of showing here. Cluster is sort of like, is basically when you're doing meta monitoring, so say we take our example of Grafana Cloud, our cluster name would be based upon, I'm assuming, which region our Loki is deployed in, and it's just an arbitrary name of showing like where your your Loki's located or which one you're specifically monitoring. It's just like an arbitrary label for identifying. That's assigned to all metrics and logs. Destinations, this is where you're writing your telemetry signals to. And so you can write these telemetry signals to your own Meta LGTM stack. That could be like an open source version. So you could keep another K8s cluster somewhere that has, say, a monolithic Loki, Mimir, and Grafana and Tempo, and you could point all of these production metrics to that meta monitoring. Or the advice we give is to use Grafana Cloud, because then you're not under any worry about meta monitoring your meta monitoring stack. So I think you did a talk on Nicole.
Yeah.
Meta monitor, and where do you stop?
Yeah.
You need to make sure everyone has uptime.
It's like different. It's paranoid observability.
Yeah.
The talk is called "Watching the Watchers." You can look it up on YouTube. It was at KubeCon.
And then like in the destinations here, basically the way we've done it is we've done it in its most basic form. So if you're using Grafana Cloud, you have the ability to tap in pre-created Kubernetes secrets. And so in this case, we're saving like our tokens and our username for Grafana Cloud in those. But you can just remove those, and you can just use basic rights if you need to. And then there is over authentication methods. There's an OAuth 2. There's actually loads. I'm trying to see where I've left these. Yeah, there's like a comment in the docs where you can actually go see the different methods. I don't know if we can actually just search that now. Where is there we go to. Yeah, so bearer tokens, OAuth 2, SIG version 4, external secrets is what I'm using, and embedded secrets as well.
Oh, look, it's Pete.
There you go, Pete again. So scrolling down from that, we sort of like get into like the juice of the config. So integrations is basically where we're scraping those curated metrics. And I think the one thing that we don't talk about is we're actually using the Alloy Helm underneath it all. And basically what these integrations are doing is they're abstracting you away from writing the Alloy config. So when you basically create an integration and put it down, we have a pre-canned Alloy configuration behind the scenes. And so when you like specify your parameters, we'll put that Alloy config in, and then we'll allow you to tweak some of those parameters through the abstraction of the values.yaml file. So in this case, we actually have two integrations running. You don't need the Alloy one. I like the Alloy one personally because that's what's doing the legwork in collecting your meta metrics. So it's good to know that you're actually scraping your Loki metrics and you're actually performing well and writing. So we have the Alloy one here. It's only writing from the namespace meta because that's where we're deploying the meta monitoring. We have the Loki integration here, which is basically saying scrape my production Loki from the namespace Loki, and select the labels from Loki particularly there. In terms of tuning, the interesting things to keep an eye on here is structured metadata. And that's basically saying when you're ingesting logs with the Loki integration is what goes into Loki labels. I find this really hard to say. It's like I'm going to say production Loki and meta Loki.
Yeah.
So these are the ones we dictate what goes into meta Loki's labels or structured metadata to stop your cardinality ballooning out of control. Because I don't know how many tenants do we have now, Dylan? Like,
I don't know the exact number, but 100 for sure.
And that's like one of those things that would be like runaway cardinality for us is to have like every tenant and like org ID, like if it was a label.
No, it wouldn't work. Like not even a single day. Yeah.
And then so
actually with that question, that raises a question for me. Like, yeah, because do we not have like doubles of everything in that case for the cardinality point of view? You're kind of making it so that those become those fields, just put them in the structured metadata. But like, are those logs actually getting duplicated still, or?
I don't think they are.
Okay.
No, it is just that you have a faster way of calling for those when you are searching for those things. Like, let's say you want to filter for a specific tenant, you'll be able to speed up your query without having to index the whole thing. But that shouldn't like cause duplicates.
Okay.
because you'll still be like emanating for that specific user, but like that tenant will just be saved in the structured metadata rather than you creating a new log stream for it. And so that's kind of like the specifics. And then the last bit, because we are using the K8 monitoring Helm, is we actually have like cluster events, cluster metrics, where you can basically bring in Kubernetes resources and monitor those directly. So the ones we advise, we actually kind of tell you which ones are required, such as CADvisor, which actually also deploys CADvisor to your Kubernetes cluster. You can turn that on and off depending upon if you already have CADvisor installed in your K8 cluster, and that creates the resource metrics for your Loki deployment, so you can see how well they're performing. And then there are a ton of other features you can enable and disable here. My gotchas here is what we've tried to do is enable the ones that you need. You can have more data, but you have to be careful of it's like a catch-22. Yeah, it's like you increase your cardinality and you potentially increase your cost by collecting all the rest of these metrics. And it's like, do you actually really need them? Probably not, but they're optional metrics if you do need them for your use case. And then finally, I'm just checking on time where we're at. The last bit is to check out pod logs. That's how we scrape our pod logs, labels to keep versus and where to scrape them from. And then the last bit to advise on here is like Alloy Singleton versus the other Alloy deployment methods. We recommend using Alloy Singleton for most community members' setups, just because it just deploys a single Alloy down. It's like low resources and will do most of the heavy lifting that you need it to do. If you have a crazy large Loki deployment and you have, say, a couple 30 replicas of ingesters and queriers and God knows how many, then we advise you to look at Alloy metrics and alloys, which deploy them as a daemon set and have basically deploys them as like a Alloy cluster and takes away some of like the heavy lifting from that single Alloy singleton, which might fall over from the pressure of too much logs and metrics. So yeah, that's kind of like an overview of like the config. We actually have docs here, which take you through the deployment method. Really, all you need to do is make sure you match up the namespaces to your namespaces of where you've deployed Loki. Make sure you have our repo and where you want to install the meta monitoring. We recommend you installing meta. And then depending upon where you're writing your data to, you might have to set up some authentication. So we'll take you through that. So in this case, we're setting up generic secrets for Grafana Cloud. And then all it simply is a deployment of the Helm, which is, I can find it in the docs, Helm install, meta monitoring Loki, and away you go. And you should start seeing data in the Loki Mixins. It's designed to populate the Loki Mixins. So if you're not seeing data there, then there's either something that we need to look at that's not collecting in the Helm, or you might have a weird label that we're not accounting for.
Okay, well, what about the gotchas you mentioned earlier about the scrape interval for Grafana Cloud?
Yeah, so there's one thing that you have to be careful with Grafana Cloud, and we like to keep it transparent here, is we expecting, if you're using Grafana Cloud for meta monitoring, it's like we expect most people to be having a metric a minute. And we have this notion in Grafana Cloud. It's like if you're ingesting metrics at a higher resolution than a minute, that actually comes as an extra cost in Grafana Cloud. And so you have to be careful of that cost. So at the moment, we're doing a 15-second interval. So we'll have 4 points a minute, because my math's right. You have to be careful of that extra interval or those extra points, because that goes into your total cost. The cost is marginal, but as you bring in more and more metrics, that's something like I don't want the community to feel like they're caught out on. So that's something to keep in mind. What you can do as a workaround is you can set it to the default 1 minute interval, but you'll have to change the way the recording rules function. So the recording rules currently expect you to have like 4 points in a minute. You can change the recording rules, so you do 4 points every 5 minutes or something like that. But it's just because we keep the recording rules equivalent to what we have internally. If you're using your own OSS deployments, this is not something you have to worry about, but it's just something you have to worry about if you're using Grafana Cloud.
Okay. We have some questions here. We're short on time, but maybe we could go through these quickly. Andre Ziviani, one of our Grafana champions, one of our favorites, has a question. Any tips on how to find what query is generating load on the cluster, ideally from which dashboard or alert rule?
Yeah, so once you know there's a query generating enough load, the right thing to do would be to look at the metrics.go log line that we mentioned earlier, and you can look at the which queries are like loading the most amount of data.
Okay. And then also there was a question from Kelvin earlier. Kelvin Ferraz says, do you have some time to compare Grafana Loki versus the Elk services? I think there's an extra question from Guru adding to that. One business, this is a migration question. Like, is there any best practices for logging for applications in the context of migrating from Elk to Loki?
I think so. I think one thing you should be careful with is that, like, if I'm not mistaken, on ELK, like, everything is indexed. So indexing more stuff is probably better in your case. In Loki, like, you have to be very careful with that. You should look at the labels and the indexes on Loki to help you filtering out data that you don't need. But you, at the same time, you have to be careful to not like exploding cardinality. So yeah, the recording with that you mentioned will probably be really helpful for you.
Okay. A question from, oh man, my Hebrew is not up to date. Sorry. Since query front end stitches querier results, does it hold the entire query memory, possibly double querier memory? Can we throttle large queries without hard limits like max lines or bytes? I'm parsing this. So query front end, okay, the query front end stitches querier results.
Right.
Does it hold the entire query in memory?
You can say that, but the way it will store the data in memory is very like optimal. So I don't think you have to run like double the query in memory. I don't. Yeah, that's you don't need that. I would say. And then you ask can we throttle large queries without hard limits. Um, it, it is hard because this is the goal of the limits to helping you like throttling bad usage. Maybe the question is why don't you want to use the limits?
Yeah, there's that extra context because I think that they also asked this in the community, not just on YouTube. They said, I know that's a bit naive, and I guess that there's some type of lazy iteration, but I still want to understand this.
Yeah, I don't remember from memory if it holds like most of it. What I remember is that like it is in a more optimal way of storing it.
I think the question is, does the query front end need to have double the memory of queriers?
No, not really.
Okay. Yeah, I think we talk about this in our Kubernetes deployment with Poison. We did a Loki community call.
About some of the sizing.
Yeah, this sounds like a sizing question. Yeah. And she does talk about the query front end there.
I think what would be cool is if they could give sort of some examples of some heavy load queries that end up getting run. And I kind of see the point. It's like they can't prevent people from running crazy queries, and that's like I agree. It's like why don't we just set hard limits? But perhaps there's like maybe like once a month they need to run a big report or something and pull a ton of logs from Loki. So yeah, it'd be cool to see what queries they want to run, and maybe we could look at another community call at some point about how you can sort of balance heavier queries with standard usage of Loki.
There was an interesting use case. So I talked to someone who presented at GrafanaCon, but I wasn't there, so I don't know if they actually talked about it. So let's not mention the customer. But he said that with Loki, what they do is they actually have a proxy. They wrote a program.
Oh, yeah.
They have a proxy, and instead of the queries going directly to Loki, it goes to the proxy, and the proxy says, this is a really bad query. Rejected. So then they really it's like they're gating a bit. They have a bit more of a safeguard so that people can't just bring down the whole installation just from a poorly performing query. And I just thought like we should not need to have people do this.
To open source it, wasn't you?
Yeah.
They said they had some work to do, but they were hoping to
Yeah,
contribute it back. Yeah, that's a cool one.
Yeah, that would be really cool. That would be a cool thing to open source. Andre Ziviani says, from my experience, front end does not use much memory.
Exactly. Yeah, I agree with you.
So maybe that's it. When we need to look at, there might be another underlining reason, and it'd be interesting to see once they bring back their meta monitoring dashboards, whether it is truly the front end that's the issue here, if there's other causations in the background that are boiling up to make it feel like it is the query front end that's causing problems.
Agreed. And from the mixes that we showed, like for the Loki reads, you can pretty much tell if the front end is the one struggling. And we also have the reads resources, which will tell you how much like resource every one of those components are using.
See, perfect. I think that's what, if you can get back to us with those dashboards, set up test letter in the meta monitoring for us, and then we can help you out further. I think that'd be cool.
Yeah, because if you need to have this stuff deployed to get the information, otherwise it's just too difficult to like. It's just conjecture basically.
Yeah,
exactly.
All right, I think that's us. I'm happy that you were able to hear and see us, and that we're like in person. There's no, we're not in separate screens. There's no latency.
Are you sure? Maybe this is all just like Gen AI, and we're all just like
these days.
Yeah. Also, I have a personal reason for logging off because I'm hungry.
Yeah.
We literally just flew in like a few hours ago. Okay, thank you everybody for joining us. Thank you, Dylan, for joining us too. Thank you for letting us rope you in. We're just like, Dylan, you're gonna
survive.
Yeah. If anyone has any questions on this topic, where should they go?
Community. We have like, if you can share the link for them.
Yeah.
The pre-canned. It was really a rhetorical question. Okay, yeah, community.grafana.com. You can find the links to our forum and to our Slack, and we're there too. So if you have specific questions, you can ask us about that, or YouTube comments. We do try to monitor those as well. Thank you everyone for watching, and we'll see you in the next one next month. Bye everyone.
See you later.